So this is the mechanical arm that I designed and built at Naples High School for my senior project. So I'll give you a little tour of how it works, how the pneumatic muscles work, and then show you the arm actually operating. So if we walk around behind it, you'll see all the stuff that makes it work. So at the bottom here we have a battery, and that's just like a motorcycle battery, a 12-volt battery. And it's hooked up to a switch and then to the gray thing here, which is a air compressor. And then the compressor has just a regulator on it and goes into 4 the silver air tanks and then into another regulator. So the second regulator regulates the pressure at 60 psi, so that means that the muscles are operating at 60 pounds per square inch. And then out of the regulator it goes into, these are going to be kind of hard to see, but there are 2 valves here. These are 2 manual toggle valves. They're 2 outs, there's 1 in, there's 1 in, 2 outs, and 2 exhausts, so it's a 5-2 valve. And then out of the valves it goes into the different muscles. So now I'll go through. Now you'll see these are not actual bones. These are wooden models, but they are based on actual bones. These are the real bones were used to generate 3D models, and then 3D models are used to cut out wooden bones on a CNC. So all of these are very, very close to actual bones, and it works out that because they're out of poplar wood, they're also fairly similar in strength to human bones. So here you have the scapula, you have the humerus, you have the ulna, and then the radius. And then the hand is just here to make it look a little less weird. I wasn't particularly interested in operating the hand. The muscles there are really too small and too many to account for this project. But basically what you have is we have these 2 muscles here. These are the biceps. Then you have 3 on the back. There's 2 here, and there's a small one on the other side. Those are the triceps. And then we have the supinator and the pronator teres on the forearm, and those are the muscles that help in rotating the hand. So it's all right now. The system's all charged up with air. So I'm going to run it in just a second, and basically what you're going to see is the pneumatic muscles work. They're actually pretty simple. Inside is a silicone tube, and then around it is a braided nylon tube. So when air goes in, the end is capped here, so when air goes in, the silicone tube fills up and expands, but because of the structure of the fibers of the nylon braided tube, as it expands, it also contracts in length. So it operates a lot like an actual muscle would on your body. So it works by contracting and relaxing, and you'll see that when I start running the muscles that they'll expand and get really big, and they'll shorten up. And then these are all connected with wires to the points on the bones where they would be connected in real life. The biceps and triceps are working pretty well right now. The rotation of the forearm is a little tricky, and I haven't quite been able to work that out completely, so that I'll run those 2 muscles, but it won't be that terribly exciting. But the other ones are working pretty well. So go and run the muscles, and you'll see them operate. So the first ones I'm going to do are going to be the biceps and the triceps. So you'll see the muscles got a lot bigger. They've also contracted in length and brought the forearm up. And the triceps will bring it back down. And then, so there you go there. And then I'll do the forearm, the rotation there. So that's rotating it a little bit, and then rotating the other way. And you'll see right now part of the problem is that the bones are rotating up over each other, where what we really want is the radius to rotate around the ulna and flip the hand over. But it's a work in progress, so. But there you go. There's the arm, and hopefully we'll maybe be able to make maybe some improvements over the summer here and get things working a little better, but there you go.